Hi everyone. So in my first video I discussed about Euclid's division lemma. Today in this video I am continuing that Euclid's division lemma, finding the HCF by using Euclid's division lemma. If bigger numbers are given, suppose for example 324 and 1024, or the numbers are given. So by using Euclid's division lemma, how can you find out HCF? So already we learned in stepwise division method or continued division method. In that process we have to take the bigger number as the dividend and smaller number as the divisor. 324, it will go 3 times. 3 times is 972. So subtraction 52, and 52 is a divisor and 324 is the dividend. It will go 6 times, that is 312. 312, remainder is 12, remainder as the divisor and 52 as the dividend, and it will go 4 times, that is 48, and the remainder is 4, and again 4 you have to take. 12, this is called as continued division method. 12, 4 3s are 12, and the remainder is 0. Whenever 0 remainder gets, the divisor is the HCF. So 4 is the HCF of the HCF of this is 4. 324 and 1024 is 4. So this how can you write as a lemma? So already we discussed A is equal to BQ plus R. A is equal to BQ plus R. This is the algorithm we'll call. And as a lemma, if you want to write down, so 1024 is equal to 324 into 3 plus 52. And again 324 can be written as 52 into 6 plus 12 as the remainder, and 52 can be written as 12 into 4 plus 4 as the remainder, and next 12 can be written as 4 into 3 plus 0 is the remainder. In such case 4 is called as the HCF. So HCF or GCD of the two numbers 1024 and 324 is 4. Is 4. So this is somewhat shortcut than directly doing the numbers previously. And next I am going to discuss about that 1.1 exercise 1.1 model sums. This is also same model. If the bigger numbers are there, we'll follow this. And second sum is using Euclid's division lemma. Prove that using Euclid's division lemma, prove that square of any positive integer is of the form 5n or 5n plus 1 or 5n plus 4. Square of any positive integer is in the form of 5n or 5n plus 1 or 5n plus 4. So actually I am discussing all those methods very easily to understand. And by this model definite question for in the public examination, it will score 4 marks. They have given they will give for this as a 4 marks question. It's compulsory one. So presentation is important. So that's why you have to write what is the given condition. In the question we discussed that using the division algorithm, Prove that square of any positive integer is of the form 5n or 5n plus 1 or 5n plus 4 for some integer n. That is the question. So what is the given? You can use the Euclid's division lemma. So using Euclid's division lemma. Already we know that Euclid's division lemma is for any two positive integers a comma b which are belongs to z plus such that a is equal to bq plus r and 0 is less than or equal to r is less than b. This is the condition. So here RTP is the square of this positive integers is in this form, so 5n or 5n plus 1 or 5n plus 4. So here proof we can write as the proof. How can you prove this? So here integer form is a is equal to bq plus r. So in this what is the form we have to take? So a is equal to 5q plus r. 5q plus r is the integer form. A is an integer. A is an integer. 5q plus r in the form. So here what b takes? B is nothing but 5. So then what are the possible reminders? The possible reminders are 0, 1, 2, 3 and 4. The possible reminders are r is equal to 0, 1, 2, 3, 4. What you have to do now? Square off. So squaring on both sides. Squaring on both sides. So that a square is equal to 5q plus r whole square. 5q plus r whole square. Okay. So these squares in the form of 5n or 5n plus 1 or 5n plus 4. That we have to remember. So 5n, 5n plus 1 or 5n plus 4. First, before explaining the proof, I will take an example. Suppose you take square of any number. Suppose 5 square you take. 5 square is 25. 25 is in the form of 5 into 5. So 5n form it is. 6 square you take. 6 square is 36. 36 how can you write? As 6 square is 30 square. 36. This as a multiple of 5 into 7 plus 1. 5 7s are 35 plus 1. So 5n plus 1 form. It is in the form of 5n plus 1. Suppose you take 7 square. 7 square is 49. How can you write 49 as 5? As a multiple of 5 you have to write because this is a divisor is b here. B is 5 here. So as a multiple of 5 only you have to write. 5 into 5 9s are 45 plus 4 you can write. 5 9s are 45 plus 4. So it is in the form of 5n plus 4. So not only like that, 8 square you can take. 8 square is 64. 64 how can you write? 5 into 12 plus 4. So 5n plus 4 form. 5n plus 4 form. So have you understand this? That means any number, any positive number which is square must be in the form of 5n or 5n plus 1 or 5n plus 4. And here coming to the sum, a square is equal to 5q plus r whole square. RHS is in the form of a plus b whole square. A plus b whole square formula already you know that a square plus 2ab plus b square plus b square. According to that you can expand a square is equal to 5q whole square as a square plus 2ab is 2 into 5q into r plus b square is r square. B square is r square. So from these first two terms, I want to take 5 as a common. So 5q whole square becomes 5 square q square. 1 5 comes out. So one more 5 is left over. So 5q square. Plus from this term, second term, 2 into 5q into r. 5 I am taking out common. So 2qr is left over. Then plus r square. Plus r square. So I am assuming 5q square plus 2qr as one of the integer. One of the integer. So this becomes 5 m plus r square, where m is equal to 5q square plus 2qr. 2qr, it becomes 2qr. Okay, so this is a square form. A square is in the form of 5m plus r square. But already we know that first only we wrote the possible remainders are 0, 1, 2, 3, 4. So we have to check for all these possible reminders whether this is in this 5n or 5n plus 1 or 5n plus 4 form or not. So if r is equal to 0, what I am taking? A square is equal to 5m plus 0 square or plus 0 square. So that is nothing but 5m, or simply we can write 5n form. M and n are equal, where m and n are equal. So n is equal to m. So you have to remember this. Next, r is equal to 1, what you will get? A square is equal to 5m plus 1 square. 5m plus 1 square. So where 5m plus 1, here also I will take m is equal to n is equal to m, both are same. So you will get a square is equal to 5n plus 1. So previously r is equal to 0, you are getting 5n form. R is equal to 1, you are getting 5n plus 1 form. And if r is equal to 2, what I will get? A square is equal to 5m plus 2 square. In place of r, this you have to remember a square is equal to 5m plus r square. That r values you have to substitute, so that you will get 5m plus 4, you will get 5m plus 4. Next, r is equal to 3. So a square is equal to 5m plus 3 square. 3 square is 5m plus 9. 9 can be written as 5m plus 5 plus 4 as a multiple of 5 plus remainder. So 5 of m plus 1 plus 4, where this can be written as 5n plus 4, where n is equal to m plus 1. N is equal to m plus 1. And still one more we have to check. R is equal to 0 or 4 also. So if r is equal to 4, what it will become? A square is equal to 5m plus 4 square. 5m plus 4 square. So 5m plus 4 square is 16. 16 can be written as a multiple of 5 as 15 plus 1 remainder. Plus 1 remainder. So 5 can be taken as common. M plus 3 plus 1. M plus 3 plus 1. So here m plus 3 can be taken as n, because that is also an integer. Again it comes r is equal to 4, a square is equal to 5n plus 1. In any case, 5n or 5n plus 1 or 5n plus 4, 5m plus 4, 5m plus 4, 5n plus 1, like this only you are getting. So what can you conclude finally? So square of any positive integer is of the form 5n or 5n plus 1 or 5n plus 4. Is it clear? In the similar way, in the similar manner, we can find out a cube of any number is also. But like these sums, we can frame so many things. In the textbook, it is given one, and here I explained another one. So to understand like that, I explained the different model. And one more sum I will explain. So using division algorithm, prove that cube of any positive integer is of the form 3r plus 1 or 3r plus 2. 3r plus 2. So cube of, here what you have to do? Cube of. Same procedure you have to follow how like the previous sum. In the similar manner, what you have to do? So given condition is Euclid's division lemma that you have to remember. A comma b belongs to z plus and a positive integer. That means a b are the positive integers. A is equal to bq plus r, where 0 is less than or equal to r is less than b. That condition you have to remember. Then based on this condition, what is the a form here? What is the integer a? 3q plus r. 3q plus r. So here b is equal to 3. Then what are the possible reminders? 0, 1, 2. 0, 1, 2. Then but in the question what is given? Cube of any number is in the form of 3r, 3r plus 1, 3r plus 2. So what you have to do here now? Cubing on both sides. So a cube is equal to 3q plus r whole cube. So cubing on both sides while doing the cubing. So LHS and RHS both should be cubed. Then remember, recall the a plus b whole cube formula. A cube plus 3ab into a plus b. 3ab into a plus b plus b cube. Recall this formula, a cube plus 3ab into a plus b plus b cube. So according to that, what a cube becomes? A cube is equal to 3q whole cube. A is 3q. Okay. Plus 3 into 3q into r into 3q plus r plus b cube is r cube. So here what I have to do? 3 I have to take it as common from the first two terms. So 3 I have to take it as common. So 3 I am taking common. So it becomes a cube is equal to 3 cube is there. 1 3 I am taking already outside. 3 square into q cube, it will be left over. In the next term, 3 into 3q into r into 3q plus r. Everything considered as one term because all are under multiplication. So 1 3 I am taking as common. So which is left over? Plus 3q r into 3q plus r is left over. Plus r cube. Plus r cube. And I will consider everything as some integer. So I am considering as a cube is equal to, which I am considering 3 square means 9q cube plus 3qr into 3q plus r as considered as x. I am considering as x. So a cube is equal to 3x plus r cube. 3x plus r cube. Where x is equal to 9q cube. 9q cube plus 3qr into 3q plus r. 3q plus r. Okay. So, now this is the condition we have to take. In this condition, we have to substitute the r values as 0, 1, 2. Then it can get in the form of 3r or 3r plus 1 or 3r plus 2. So, r is equal to 0, remainder is equal to 0. Then a cube becomes what? 3x plus 0. So where x is equal to r you can take, then this can be written as 3r, where r is equal to x. If r is equal to 1, then a cube is equal to 3x plus 1 cube. That is nothing but 3x plus 3r plus 1, where here also r is equal to x. Then if r is equal to 2, then a cube is equal to 3x plus 2 cube. That is nothing but 3x plus 8. It can be written as 3x plus 6 plus 2 as 3 common, x plus 2 plus 2. So x plus 2 taken as r, then this can be written as 3r plus 2, where r is equal to x plus 2. Is it clear? So, if r is equal to 0, 1, 2, the cube of any integer is in the form of 3r or 3r plus 1 or 3r plus 2. Is it clear? Okay. Then I'll discuss in one more question. These two models from textbook only. Textbook sums are different and these sums are different. Why I'm explaining other sums means, so by understanding these models, you can solve that also textbook sums. And in 1.1, last sum is there. Show that one and only one out of n plus 2 out of n plus 2 or n plus 4 is divisible by 3 where n belongs to any positive integer. So exercise 1.1 in real numbers for 10th standard TS and AP State standard 10th standard syllabus from that textbook. 1.1 fifth question is, show that one and only one out of n plus 2 or n plus 4 is divisible by 3 where n belongs to some positive integer. So here what is a? Here a is nothing but n. A is nothing but n. So you have to apply the Euclid's division algorithm or EDL, simply Euclid's division algorithm. So what is the definition of that statement of that? A is equal to BQ plus R, 0 is less than or equal to R is less than B. So given that these n plus 2, n plus 4 are divisible by 3, he has given. Divisible by 3. So if it is divisible by 3, then what is B? So here B is equal to 3. A is equal to n and B is equal to 3. Then automatically possible remainders are what? 0, 1, 2. 0, 1, 2. Okay. So that means here we will get n is equal to 3q plus r. N is equal to 3q plus r is a integer. So in this integer we have to check for r is equal to 0, n is divisible or n plus 2 is divisible or n plus 4 is divisible, we have to check. So if r is equal to 0, n is equal to what it will take? 3q only plus 0, because 3q plus r is 0, n is equal to 3q. 3q means 3 into some integer. So it is divisible by 3. Divisible by 3. Okay. And next we have to check for r is equal to 0, n plus 2 is divisible or not. N plus 2. N plus 2 means for n we are adding 2. So n is what here? 3q plus 0. So 3q plus 2 we have to add n plus 2. As 3q plus 2, 2 is not a multiple of any 3. So this term is not divisible by 3. Not divisible by 3. And we had to check for n plus 4 also. So 3q plus 4 it becomes. This is also not divisible by 3. So out of n plus 2 and n plus 4, out of n plus 2 and n plus 4, which is divisible? Only one is divisible. N is equal to 3q is divisible by 3. N plus 2 is not divisible, n plus 4 is not divisible. In the same way, if r is equal to 1, we have to check all the three conditions. Out of the question is one and only one out of n plus 2 or n plus 4 is divisible by 3. So if r is equal to 1, I'll check for n. So n becomes what? 3q plus 1 is not divisible by 3. Not divisible by 3. And you have to check for n plus 2. N is already 3q plus 1. N is added by 2. So 3q plus 1 is also added by 2. So it becomes 3q plus 3. So 3q plus 3 means 3 of q plus 1 we can write. So this is 3 into L or 3 into R, some integer. So it is divisible by 3. Now we have to check for n is equal to 4. So n is what actually? 3q plus 1. And n is added by 4. So 3q plus 1 is added by 4. It becomes 3q plus 5. And 5 is not a multiple of 3. So 3q plus 5 is not divisible by 3. R is equal to 1 also. Out of 3 conditions, which is divisible? N plus 2 is divisible by 3. One and only one out of those 3 is divisible by 3. And we have to check for R is equal to 2 also. R is equal to 2. If R is equal to 2, what is n value? 3q plus R. So 3q plus 2. 3q plus 2, as 2 is not divisible by 3, it is not a multiple of 3. So total term is not divisible by 3. Next, what you have to check? N plus 2. N plus 2 means what is n? 3q plus 2. And n is added by 2. So 3q plus 2 is added by 2. This becomes 3q plus 4. This is also not divisible by 3. Not divisible by 3. Now we have to check for n plus 4. N is what? 3q plus 2 is added by 4. It becomes what? 3q plus 6. And 3 is common, q plus 2. So 3 into some integer 3r is divisible by 3. So according to the question, out of those 3, one and only one is divisible by 3. So here which is divisible by? N plus 4 is divisible by 3 if r is equal to 2. So what is the conclusion finally? One and only one out of n plus 2, n plus 4 is divisible by 3, where n is a positive integer. So these are the main important questions which can be asked in the public examination for 4 marks questions. Out of those 3 questions, surely you will get one of the question. So all the best, children.